This is the next question in front of us. For a periodic signal v of t equal to 30 sine 100t plus 10 cos 300t plus 6 sine 500t plus pi by 4, the fundamental frequency in radians per second is. So, in this question, we have a signal which is a composition of three different sinusoidal waves. Okay, the first thing you have to remember is if you see a phase shift, ignore this, because the phase shift is not going to affect any kind of time period or frequency. So ignore this. Now we have three different sinusoidal waves. So I will give you a thumb rule. If a signal is such that x of t is equal to some okay, capital A sine a1 by b1 into t plus capital B sine or cosine, whatever, no problem, a2 by b2 into t plus c sine a3 by b3 into t. Yeah, fine. If this is a signal, then the fundamental frequency of the signal is let me call it as omega 0, will be equal to HCF of A1, A2, A3, etc. If it has further terms, divide by LCM of B1, B2, B3. So this is the thumb rule you have to remember in this kind of questions. So this is the thumb rule. All right. So in the given question, v of t equal to 30 sine 100t plus 10 cos 300t plus 6 sine 500t. So this denominator part is absent, or it is 1. Okay. So therefore the frequency omega 0 is just HCF of A1, A2, A3. That means 100, 300 and 500, right? Right, 100, A1, A2 is 300 and A3 is 500, correct? So 100, 300, 500 divided by LCM of, actually it is 111, which is equal to 1 itself. So what is the HCF of 100, 300, 500? The highest common factor inside 100, 300 and 500 is 100. Okay, 100 divided by 1 is 100 radians per seconds. So the correct answer turns out to be option A.